Hello everybody, how you doing? Hope everybody's doing fine, I really do. And we're going to get into this video here in just one little second. Hope you like the new intro, and this is what we're going to use from now on. So much love, fasten your seatbelt, and let's get her going.
Off the globe. So in 48 hours time, we have a stair step of deep earthquakes, for instance, over here, going from extremely deep all the way up to somewhat deep, and then going up to shallow at the surface. The surface earthquakes or the shallow earthquakes are hugging the earth, so you can tell the difference. I'm going to be turning myself off here on the screen, and we're going to turn on a display capture to go dive into what's going on. But before we get into the earthquakes, I've got something we are going to have to spend a few minutes talking about, and this is breaking news that came out in the past day or two, coming over from phys.org, and it's also breaking. Rebecca, my moderator and fellow researcher, has a great video out on it. You guys should go over to my Twitter page and check it out. Researchers have turned liquid metal into plasma. And you can see what I say here. Wow, 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 wow. Here, let me turn on the screen, make sure you can see it. Yep. Researchers have turned liquid metal into plasma. Hate to say I told you so, but never mind, blah, blah, blah. Okay, well, we can go over here and go to the actual phys.org article or check out Rebecca's video. And in the article, it is amazing what researchers have done. And I'll read you the first paragraph on here, and then we'll talk about what they've actually found. So most laypersons are familiar with the three states of matter as solids, liquids, and gases. But there are other forms that exist. Plasmas, for example, are the most abundant form of matter in the universe, found throughout our solar system, in the sun, and other planetary bodies. Scientists are still working to understand the fundamentals of this state of matter, which is proving to be ever more significant, not only in explaining how the universe works, but in harnessing material for alternative forms of energy. For the first time, researchers at the University of Rochester's Laboratory for Laser Energetics, LLE, have found a way to turn a liquid metal into a plasma and to observe the temperature where a liquid under high density conditions crosses over to a plasma state. Their observations, published in Physical Review Letters, have implications for better understanding stars and planets and could aid in the realization of controlled nuclear fusion, a promising alternative energy source whose realization has eluded scientists for decades. It goes on to explain what is a plasma, and I'll just read it to you, I guess. We'll keep reading. Plasmas consist of a hot soup of free-moving electrons and ions, atoms that have lost their electrons. Think about that, okay? So you have an atom, it's losing its electrons. That easily conducts electricity. Although plasmas are not naturally common on Earth, they comprise most of the matter in the observable universe, such as the surface of the sun. Scientists are able to generate artificial plasmas here on Earth, typically by heating a gas to thousands of degrees Fahrenheit, which strips the atoms of their electrons. On a smaller scale, this is the same process that allows plasma TVs and neon signs to glow. Electricity excites the atoms of a neon gas, causing neon to enter a plasma state and emit photons of light. Now, let's just stop right there. Everybody's familiar with a plasma globe. You could touch your hands to the outside of the glass, and the plasma expands out to touch your fingertips, but it doesn't come through the glass. The glass is the insulator, but it's just enough to allow for a flow of electrons, almost like a static charge, just a little bit to go into you, thus drawing the plasma out to the edges of the container, in this case the glass ball that we're all familiar with the neon gas inside and the tendrils going around on the inside of the plasma globe. But in this case, what we're talking about, instead of neon gas, we're talking about vaporized metals themselves, iron, nickel, under such pressure that it's vaporized into a plasma state. And like they say, plasmas consist of a hot soup of free-moving electrons and ions, atoms that have lost their electrons, that easily conducts electricity. Okay, so this is something done in the laboratory. Now, we could go on in the article. We can talk about, you guys can go read it. It's very interesting what they're talking about in how they're able to do that and under what pressures and temperatures. We're talking about up to 80,000 degrees Fahrenheit. I mean, 180,000 degrees Fahrenheit. I'm sorry, did I say 80,000? Okay, I mean, do you see this, right? So we're talking about tremendous temperatures, hotter than the sun. So, plasmas. Now, this gets me into something that I've talked about for a long time, which is the plasma connection to the core of the Earth. Now, let me show you something. We're going to go look at a video here, if I can find it. Let's see. Here it is. Spinning plasma ball experiment. This is from Mr. Fix-It Rick over on YouTube, which you're going to have to go subscribe to this guy. He's an incredible channel. I'm going to open up the video. We're going to kind of fast forward it through here, and I'm going to show you something. In this experiment here, let me turn up. Here we go, just right here at the beginning. Okay, do you see that? All right, again, let me play this really quick. This right here, what we're looking at on the screen, is a standard plasma globe that you would play with. The kind with the glass ball around it. But this has been taken and put into a device that rotates it very fast. Now, we're going to go into the video. We're going to fast forward just a little bit. You can go watch, there's Mr. Fix-It Rick. Awesome. Here's the device. Basically what this is a motor. This is mounted on top of a acrylic plate to insulate it. The plasma globe's on the inside, battery powered, and it's secured down to the plate, which this whole thing is rotated with this handheld, I guess, remote control. This is, I guess, from a car. It's a little remote control car where you can turn it up as a variable speed dial there. And he brings it up to several hundred first RPM, then several thousand RPM. Now, here's the amazing thing. In the experiment, when the plasma globe is on, right here, well, let's see. You'll see. Here it is, as you would see it normally with its tendrils, and this is really electricity, electrons escaping out to the insulator, which is the glass. Now think of this as the core of the Earth, and that the glass is the top of the plates, or the bottom of the plates. So the plates of the Earth would be around the plasma at the center. And instead of a post, and instead of neon gases, we have a center sustained core that's compressed on all sides, so it doesn't need a post. But the post that's providing power in this globe here, you could just think of the sun providing the power coming in from the poles of the Earth at the North and South Pole, providing enough power to, of course, power this plasma core at the inside of the Earth. Now, these are the tendrils as you would all see it, standing still. Now, what's going on here, the reason the tendrils are bouncing around, and I've got several of these myself, you can look at them very close. You can even get out a magnifying glass and look at the post, and what you'll see is that each tendril itself is rotating almost like a small vortex. Not like a tornado, but it's rotating. Each tendril is. And you can touch your finger to the outside of the glass, and you can watch a tendril seek out your finger. And if you look close where you're touching, or if you press your finger good against it, you'll see a rotation of the plasma itself, like it's rotating like a pinwheel. So the plasma itself is what's called oscillating. It's oscillation is just another word for rotation. It's rotating, spiraling through space-time. I mean, if it was standing still in space-time, it would just be rotating in a circle. But it's going through space-time, moving forward through space-time, so it's actually a corkscrew. Okay, you understand that? Okay. So these electrons that are moving through space-time, they're rotating in perfect spheres, I guess. It's a good question. It could be oblong, who knows? But it's rotating. All right, that's the point of this. That the plasma itself is oscillating, and all electricity oscillates, by the way. No matter what form it is, whether it's in a wall socket, whether it's a lightning bolt going from ground to cloud. We'll talk about that in a second. But now look what happens when you bring this into a rotation on its own. When you take the already rotating plasma, already oscillating, and bring it up to several thousand RPM, look what happens to the free-floating tendrils that are random. Watch this. 2,000 RPM. He turns it up. Now watch. Starts bringing it into slight rotation. Hold on. Okay. All right, bring it up. Now watch what happens. Do you see this? Let me pause it right about here. Or right there. That's a good shot of it. So this is all happening inside the gaseous state where the electrical current that's already oscillating is brought into what I'm calling a hyper oscillation, a super oscillation, an ultra oscillation, a something greater than already oscillating. And it's very fast. Of course, the oscillation is very fast, several thousand RPM. In this case, several hundred. He hasn't even brought it up to several thousand yet. And it breaks off into a definitive North Pole, and the South Pole is blocked by the post, of course. Now imagine this free floating inside of the Earth, where all compression is going on the inside, and as the experiments now proved, vaporized iron, vaporized nickel instead of neon gas, and then instead of an electrical charge from the wall or a battery, we're talking about a huge amount of power coming from the poles, the North Pole and South Pole, where it's capturing charged particles from the sun, like plugging into the sun. So, it breaks off into a definitive North Pole, but look what else it breaks off into. Tropics and an equator, watch. The tendrils floating through the gases that are charged and oscillating take an organization, a magnetic field of its own. And then he slows it down, and look what happens. Well, we'll just let it play through. There's 2,000. There you go. You see it. And it's resetting itself. It's going back down to the tropics. Now he brings it back down. And boom. Back down to quote-unquote random. But really that random is it's just seeking a random way to ground because it has no way out to oscillate out on its own. So, it's my contention that this is happening on the inside of the Earth and that it's oscillating faster than 2,000 RPM. Now, we can go through the video even more. They do some really interesting things. I mean, he gets the RPM counter out, everything, the laser. But then they attach to the outside of the globe like a piece of tinfoil. Look at Mr. Fix-It Rick is awesome for doing this. Why does the plasma arc go to the center of the globe when it rotates? It's forming its own magnetic field. That's it. Now, I think, I can't prove it, but if you did this experiment right, or with a more powerful plasma, or maybe even with this plasma, if you had a way to measure it really close, there may be a gravity effect. Anti-gravity effect. I don't know. Either pulls it in or pushes it away. That it produces its own gravitational field, and that this would be what causes quote-unquote gravity. It would explain why asteroids that are big enough, quote-unquote, big enough, well, what would big enough be? How about more like dense enough? How about more like a concentration of ions that were a plasma starting to form inside of a body that's big enough? So bodies that aren't big enough don't generate their own plasmas at the core, therefore they don't have a gravitational field or a magnetic field. And that dead planets used to have these, and that they eventually either lose their power, lose a connection, or something interferes. Now here's where they put the tinfoil on the top. They put a tinfoil hat on this thing, and look what it does. Of course, just like putting your finger to the outside, it's going to draw the full magnetic field, but in this case, it draws the full magnetic field of the whole plasma globe to one central tendril. And you can clearly see it's getting excited to a point of pretty heavy. So it's all focused on one spot. Of course, now imagine on the outside of the atmosphere, up in the ionosphere, there's a concentration of charged particles from the sun. What are you going to get? You're going to get air glow. You're going to get northern lights. You're going to get excitement in the air up above the poles, which ties in with how this is all being fed. It's being fed power from somewhere, which gets me into my years of research that I've done, which I'll take you over here, where I've posted this. You guys can check this out if you want to see this. Behold, Tattooed 1009 did an experiment. My buddy, down in Florida, 2013. Now this has to do with HAARP. Radio waves in the atmosphere, not down in the ground. Tattooed was able to vaporize steel, and I'll show you, it's in a video so you don't have to take my word for it, using a home ham radio. Here's all the specs on the radio. 100 watt radio, put through 4 500Z tubes, bringing it up to 3,400 watts. 3,400 watts, put down an antenna, vaporized the steel, and let me just fast forward it here. Here are you can see it on the screen. This is steel, and you see the plasma that's forming on this right there. That's not flames, that's plasma. That is the steel releasing free ions as the radio waves are punching down this short antenna, and the radio waves are too powerful to be contained inside of the steel. That it's the wrong length antenna to put this powerful current down. And what happens? The steel vaporizes into a plasma, and it turns the steel into slag. It leaves all the impurities left behind, and the iron ore or whatever it is that's vaporizing out of it. Now, he replaces the antennas and does it again, and he talks through his microphone, and let's just get it in here. Where is it? Right about in here. And he talks through the plasma. Do you hear that? Hello? Here. He does it even more and talks through it. And you see that? It's almost like a welder's torch. Now you have to listen close in the video to hear him talking. What's happening, the way you're able to hear him talk, is that this plasma, as it's coming off the tip of the antennas, is vibrating like a speaker. And it's causing vibrations in the air, just like a speaker does. And so therefore, this is producing a very trebly audio through the air as this is oscillating, as this is vibrating, just like a speaker would. But it's just the air itself. It's the plasma, the flames themselves are what's causing his voice to be heard, even though he's talking inside the house and it's coming out of the antenna. Now you can get a balanced version of one of these. Well, not this, where it doesn't melt, but where the plasma or the electrical arc produces a trebly speaker sound. So why am I showing you this? Because this ties in with the core of the Earth. That if radio waves will melt steel at 3,400 watts, and we're probably dealing with tens of trillions of watts or more down in the core of the Earth, well, this gets into HAARP. This gets into how does it get captured and taken down to the core of the Earth. Now, I'm not saying HAARP is doing this. I'm just using HAARP as an example. That here's a diagram, perfect example right here. HAARP up in Alaska. But how does this work? Well, the sun sends out charged particles, which then intersect with the Earth's magnetic fields. Now, here they have HAARP injecting radio waves VLF, but charged particles come in and get caught up in the magnetic fields. They get taken to the North and South Pole, where we get air glow at the North and South Pole from the amount of power that comes in. Now, that air glow is pretty much just like what we're dealing with here at the ground level coming off those antennas. A superheated region of air that vibrates and produces the radio waves. The vibrating of that actually causes sound waves. Okay, that's at the ground level. Now, up in the upper ionosphere, they can target, for instance, like this in this diagram here, you have two ground-based stations. Well, you have a ground-based transmitter. Well, this is another example from Jim Lee at Climate Bureau, showing the HAARP transmitter or array down here, and they target it up to a square in the sky, but it's actually a sphere. It turns out it's a ring. But they target it up to an area in the sky, and it begins to glow, just like the Northern Lights, but it's smaller, and it's made from a man-made system, maybe a few miles wide. Looks just like this. As a matter of fact, this is from phys.org. This is from HAARP, these diagrams. This is actually a picture, not diagram, picture of the air glow in IR. So a sphere, they called it, in the sky. So this sphere acts like a mirror. They call it an artificial ionospheric mirror that reflects the radio waves back to other places. So in this diagram here that Jim Lee has, showing that they create the artificial ionospheric mirror. It's called an AIM. Imagine this glowing up in the sky, or invisible, either or, and then having a radar station many miles away, and let's say a military base, and maybe a flying plane, and they're all bouncing their signals up to the spot in the sky, which then reflects it to other spots like a mirror perfectly. Now that's reflecting radio waves in the upper ionosphere using plasmas. Now what do you think is going to happen down inside the Earth? The exact same thing, but it's going to reflect, instead of high frequency and reflecting radio waves, we're talking about what's going on down in the core of the Earth, which ties in with HAARP, in particular VLF, very low frequency. This gets back to plasmas. Plasmas generate VLF. As a matter of fact, that's how they're able to use HAARP, the high frequency facility in Alaska, to generate very low frequency. Right? The VLF one-hop buoy experiments from down at New Zealand, off the coast of New Zealand, where they placed a buoy off the southeast coast of New Zealand for the magnetic conjugate point for HAARP, where VLF signals, where they broadcast high frequency up into the atmosphere, that high frequency converts into the plasma that we're talking about, but up in the atmosphere. That then generates VLF like a giant bass drum. And that VLF goes up in magnetic bands that goes all the way out into space, very far, thousands of miles, and curves back around, following what's called a magnetic conjugate point. The magnetic conjugate point is the South Pole conjugate to the North Pole. So like an antipode, but magnetically speaking. And the radio waves go down to those points, the magnetic conjugates on the opposite side of the planet, the VLF. When the VLF gets down to a certain level, Mother Nature converts it back to HF. That HF goes down and reflects basically off the Earth and comes back up and reverberates back to the transmitter. They placed a buoy down off the coast of New Zealand to detect how far the VLF comes down, where it converts to HF, where it goes down and reflects off the ocean floor and the crust, and then bounces back. And it can reverberate for many days depending on how powerful the system is that plucks the strings of the magnetic field. That's from HAARP. But now imagine the sun. The sun doing the same thing, but it's coming in from another direction. It's coming in from the outside, and it's much more powerful. Gets trapped up in those magnetic bands that go down to the core. The core again. Ground is the core. So if this is going to ground, you can connect that all the way down to the point of the Earth. See, quite literally, you could connect this into a point where they both come together at the center of the Earth. Those magnetic fields. Guess what plasma produces? Getting back to the artificial plasma ionospheric mirrors. Huge magnetic fields. Or getting over to Mr. Fix-It Rick. If we were to have a EMF magnetic measuring device, we would probably detect huge magnetic fields coming off of this once it's brought into a hyper-oscillation. Now, this is done with neon gas in a small container of, 5 volts? 5 volts doing this. Imagine what could be done with trillions of watts or more going down to the core of the Earth. Which gets me back to the original article that I posted, which is, behold, they have now figured out that liquid metals can vaporize into plasmas. And if that's the case, under high density and pressure, what do you think's down at the core of the Earth? High density and pressure, nothing more than. So this proves something huge. What? That the core of the Earth is not a solid ball of metal. That the core of the Earth most likely is vaporized metals that are hyper-oscillating, rotating extremely fast, producing their own magnetic field, and possibly creating its own magnetic field that also may have a gravitational effect. We may be finding the source for gravity itself. Not just mass. That it's not just mass that has gravity, that the reason mass has gravity is because there's an accumulation effect at the center of the object, at the core of the object, and once you reach a certain threshold of mass, obviously, that's a cascade effect that produces a plasma. and that plasma then has its own gravity. I don't know. I'm just proposing it, that it's possible. Somebody who's much smarter than me is going to have to go do that experiment and the calculations and everything. Now, this gets into earthquakes, because guess what? I mentioned VLF, I mentioned plasmas, I mentioned HAARP, and I mentioned the core of the Earth. Core of the Earth is plasma, therefore it must be producing VLF. Plasmas produce VLF, very low frequency, especially when they're widespread like this, so big. So a widespread plasma vibrating like a bass drum, producing what? VLF, very low frequency. Or possibly super low frequency, both. Well, what's VLF? I already talked about it with HAARP. But why am I relating this to earthquakes? We need to go search something. Gorkha, Nepal, VLF. And what we're going to find are all sorts of articles from Nature. Look, National Institute of Health.gov. What are they doing with it? Here, let's click on this one. What is the NIH doing? Medicine National Institutes of Health. Look, this is crazy. Anomalous variations of VLF sub-ionospheric signals in mesospheric ozone prior to 2015 Gorkha, Nepal earthquake. Let me simplify that. VLF showed up coming out of the plates, out of the faults, and out of the plate boundary in Nepal just before the big earthquake. And it went up into the ionosphere. The waves are so tall, so big, they're thousands of miles long. The waves, VLF, SLF. So imagine a wave that is coming up from the core or from the magma very far down below, hundreds if not thousands of miles down, and going up into a peak and then coming back down, and it's a wave. It's a VLF, a very low frequency. So everybody understands a wave of a frequency, and that the height of the wave is coming up and going up into the ionosphere and then going back down. And it's spanning thousands of miles out. That's not my take on it. That's the studies and what they detected using, well, I mean, look, they talk about it, how they were able to detect it, VLF signals in the D region of the ionosphere during and prior to the Gorkha, Nepal earthquake. Now, it's not just Gorkha, Nepal. We can go search something else. VLF, earthquake, Japan, 2011. There we go. Broadband ELF VLF radio recordings 0.2 to 40 kilohertz were made at a site in Onagawa, Japan, 102 kilometers, epicenter of 9.0 March 11th. They detected VLF and ELF coming up and disturbing the ionosphere. Or maybe I need to add ionosphere on here. There we go. All online Wiley, all the main, look, Department of Interior. Oh boy. Well, what they say in this is basically the same thing about the Gorkha, Nepal quake, that ionospheric disturbances were detected just before. So VLF is coming up and out of the planet. What do we know that produces VLF? Only one thing. Naturally speaking, one thing produces VLF. Naturally now. Obviously, plasmas. So humans are creating plasmas using things like HAARP up in the upper ionosphere. Then we could get into the inner planet. Let's see. Inner planet magnetic field. Here we go. Okay. Oh, not on other planet, of course. Oh, well, I don't know. If this will probably be the one that doesn't come up. It's not coming up. Okay, well, I'm not going to fart around with that now. That's something we looked up previously. It kind of doesn't really relate. I just wanted to show it to you. The inner magnetosphere of the Earth. But you can just understand it by the exterior magnetosphere of the Earth. The one I just showed you with HAARP. That going out from the North Pole and out and around down to the South Pole, imagine magnetic field lines connecting all over the planet, but they're not perfectly coming from the North Pole. For instance, HAARP up in Alaska has a magnetic conjugate point down here off the coast of New Zealand. So it's not a perfect North Pole, South Pole connection. You see that, right? Okay. But imagine a huge arc that goes from HAARP up at Fairbanks, Alaska, or Kokona, I mean, and goes all the way down out to here. But In that all the way down there's a huge reach that goes out into space. And that huge reach is the magnetic field of the Earth. And that the VLF and radio waves from the inner core of the Earth are following that, coming up out of the planet and going up into the ionosphere, being detected before large quakes. So something's producing that VLF. Now we know. Since metals vaporize into plasmas under certain densities, well, then this takes us back to the article that I posted, which is that then goes into the core of the Earth, and liquid metal turning into vapor, turning into a plasma globe, but on steroids. And so hot and rotating so fast. Now the inner core would be rotating, the outer magma would be rotating, and then the outer plates would be also rotating, but they'd be not connected. We're talking about a plasma at the center, a liquid, and then a solid outside. And we're on the solid. We're on the surface of the solid on the outside. We are on the outside of that plasma globe, the glass. Imagine we're walking around on the outside of that. So then that takes me back to the earthquakes. So now we can get into the update. I had to spend a lot of time talking about this. The fundamental idea here, or something I've been proposing, is a hypothesis for a long time. And now that hypothesis, well, that can go up to maybe a theory. I would say it's almost proved. Now we need to go down in the core and find it. So we have deep earthquakes that are hammering in on the underside of the plate, coming up, well, from hundreds of kilometers down inside the planet itself.